students, welcome to Sunil's tutorial. I'm Sunil Birwani and today we'll be doing the chapter called as oscillation. Fine, let's see this. Take down the sum please. Find the maximum velocity. Find the maximum velocity of a particle. Find the maximum velocity of a particle performing linear SHM. Find now the maximum velocity of a particle performing linear SHM. The maximum velocity of a particle performing linear SHM is 0.2 meters per second, and the maximum acceleration is 0.8 meters per second square. Calculate the period and the amplitude. Calculate the period and the amplitude. Calculate the period and the amplitude. Now guys, I can say that V max we know is A omega. A acceleration max is nothing but A omega square. Divide the two equation, I can say A max upon V max is nothing but A omega square upon A omega. Therefore, I can say that 0.8 upon 0.2 is nothing but omega. So, in which case I'll get omega is 4 radians per second. Right? Once you know omega, you can say but omega is nothing but 2 pi upon t. Therefore, I can say t is 2 pi upon omega, in which case I'll get the value of t, that is 2 into 3.14 upon omega 4. So you'll get the value of t as 1.57 seconds. Once you get t, then you can find out, they've asked you to find out, calculate the period and the amplitude, right? I can say V max is nothing but A omega. V max I know is 0.2, A omega I know is 4. Therefore I can find out the amplitude. Amplitude will be 0.05 meters. Take down next one please. A particle performing SHM. A particle is performing SHM. A particle is performing SHM along a path of length, along a path of length 16 centimeters, along a path of length 16 centimeters. If its maximum velocity is 12.56 centimeters per second, calculate the period. Calculate the period. Now guys, understand something. When they say that a particle is performing SHM along the path of length 16 centimeters, path means from mean position to one extreme and from mean position to other extreme. So when they say path of SHM, that means that length will be 2a. Now fortunately for us here, the amplitude and the velocity both are in CGS system, so I don't need to convert. I can say that 2a is 16, therefore I can say a is 8 centimeters. V max is nothing but A omega. I know V max, I know A, I can find out omega. Right? Once I get omega, I can say omega is 2 pi upon t. First use the first formula to get omega. Then using omega you can get the value of t. The answer for this sum should be 4 seconds. You should get the value of t as 4 seconds. Next, take down next one please. A particle, you can copy the answers later. First go on taking down the questions. A particle performs SHM. A particle performs SHM of amplitude 20 centimeters. A particle performs SHM of amplitude 20 centimeters and has a maximum velocity of 200 centimeters per second. What is the displacement? What is the displacement when the velocity is 120 centimeters per second? What is the displacement when the velocity is 120 centimeters per second? First of all, I can say V max is equal to A omega. V max I know, A I know, I should be able to get omega from this. Once I get omega, then I can say V is equal to omega root of A square minus X square. V I know, omega I know from here, amplitude I know, I should be able to get the value of X, that will be my displacement, right? I could say that V upon omega, the whole square will be A square minus X square. Therefore, I will get the value of X square as A square minus V square upon omega square. So you will get your value of X square from here. Then take square root and you will get your value of X. Right? The answer should be X is 16 centimeters. Next, state down exam please. Two parallel SHM are given by x1 is equal to 10 sine 8 pi t plus pi by 6, and x2 is equal to 20 sine 8 pi t meters. Find the resultant amplitude and the phase of SHM. Find the resultant amplitude and the phase of SHM. Find the resultant amplitude and the phase of SHM. Right? From this equation I can say that A1 is 10 meters. This is in meters. A2 is 20 meters. Then I can also say that alpha 1 is pi by 6 and alpha 2 is 0. Once you have this, then we have done composition of two SHM. So from there we know that the resultant amplitude is going to be square root of A1 square plus A2 square plus twice A1 A2 cos alpha 1 minus alpha 2. You have all the values, you should be able to substitute and get the resultant. And you can also find out the phase. Delta is tan inverse of this, also we've derived, which is going to be nothing but A1 sin alpha 1 plus A2 sin alpha 2 upon A1 cos alpha 1 plus A2 cos alpha 2. Right? The answer for this sum should be, substitute, get the answer. Resultant amplitude is 29.1 meters and the phase is 9 degrees 54 minutes. Take down next sum please. The velocity of a particle performing SHM. The velocity of a particle performing SHM are 12 centimeters per second and 13 centimeters per second. When it is at 13 centimeters and 12 centimeters, when it is at 13 centimeters and 12 centimeters from the mean position, find the amplitude and the period. Find the amplitude and the period of the SHM. Now we know that V is equal to omega root of A square minus X square, right? In which case I can therefore say that V1 is equal to omega root of a square minus x1 square. The amplitude will remain the same. V2 is equal to omega root of a square minus x2 square. Divide equation 1 and 2. If I divide equation 1 and 2, this is my equation 1, this is my equation 2, I'll get V1 upon V2 is omega cancel square root of a square minus x1 square upon square root of a square minus x2 square. Get rid of the square root by squaring both the sides. So I'll get V1 square upon V2 square is a square minus x1 square upon a square minus x2 square. V1, V2, x1, x2 I know. So when I solve this, a is the only unknown. I'll get the amplitude from here. Once I get the amplitude, when you solve this, you will get your amplitude. Then you can substitute that value of amplitude in the equation. V is equal to omega root of a square minus x1 square. V I would know, amplitude I found out from here, displacement I know. So I'll come to know the value of omega from here. Once I know omega, then I can say omega is nothing but 2 pi upon t. So the second formula will give me the value of omega, the third formula will give me the value of t, right? Solve the sum, get the answer. Answer for the sum should be amplitude is 17.69 centimeters and time is 6.28 seconds. Next, take on next sum please. A particle performs linear SHM. A particle performs linear SHM of amplitude 8 centimeters. A particle performs linear SHM of amplitude 8 centimeter and its period is 4 seconds. Find the time taken by it. Find the time taken by it to describe a distance of. Find the time taken by it to describe a distance of 2 centimeters from the positive extreme. 2 centimeters from the positive extreme. 2 centimeters from the positive extreme. Right? Now let's see this. 2 centimeters from positive extreme. That means the displacement is going to be 8 minus 2, 6 centimeters. The displacement of the particle is going to be 6 centimeters. Because when you consider displacement, you have to always consider displacement from mean position. So if it is 2 centimeters from positive extreme and the total distance is 8 centimeters, that means the displacement is going to be 6 centimeters. First of all, I can say omega is nothing but 2 pi upon t. T I know, so I will come to know the value of omega. Once I know the value of omega, I can use the formula for displacement. Displacement is equal to A cos omega t when the particle starts from mean position. We have done this derivation. Since the particle is starting from, it starts from extreme position. Therefore, this is A cos omega t. Fine, did we get this in here? Since the particle starts from extreme position, displacement is going to be equal to A cos omega t, and you will be able to get the value of displacement from here because x you know, A you know, cos omega you know, t is the only unknown that you have. So you should be able to get the value of t, right? You will get the answer of t as 0.46 seconds. Next, take on next one please. At what distance is the kinetic energy of a particle performing SHM? At what distance is the kinetic energy of a particle performing SHM? The kinetic energy of a particle performing SHM of amplitude 20 centimeters, three times its potential energy. Now guys, kinetic energy of a particle performing SHM is given by the formula half m omega square a square minus x square. Potential energy of a particle performing SHM is given by the formula half m omega square a square, right? But they have given us that kinetic energy is equal to 3 times potential energy. That means I can say half m omega square a square minus x square is 3 into half m omega square a square. So m and m gone, omega square gone, 2 into 1. So you will get a square minus x square is 3 times a square. You know a, you should be able to get the value of x here. Answer should be x is 10 centimeters. Right, take down next one please. A particle of mass 400 grams, a particle of mass 400 grams, a particle of mass 400 grams performs an SHM of amplitude, performs an SHM of amplitude 0.2 meters and the period is 6.28 seconds. Find the kinetic energy and potential energy. Find the kinetic energy and potential energy when it is at a distance of, find the kinetic